overall Gini. First calculate overall information. Overall information formula is this. Okay. And in your gain will be overall information minus information after splitting. So first let's calculate overall information. Overall information means how many positive classes are there? 4. How many negative classes are there? 5. So calculate with formula 4 by 9 into log to the base, and this, so you will get this one. Okay, this is your overall information. Next, expected information needed to classify tuple into Q1. Okay, now based on Q1, what is the formula? Same, it is all similar. Okay, just here if you see the difference is we have got log here. Okay, we are using entropy formula. So information of Q1, I mean information that you gained after you splitted the table based on Q1. 4 by number of how many classes at Q1 with type T? Total how many values for I mean for type T? 4. 4 by 9 into entropy of Q1 with type T. How do you calculate? Minus 3 by total 4. Probability of class positive is 3. So 3 by 4 log, and then probability of negative 1 by 4, and then log. Similarly, for type F, for this partition, type F, so you are partitioning your Q1 with type T and type F. So how much information you are gaining, that's what we are trying to calculate. Okay, so this is information you got after splitting based on Q1. So what is the gain that you got? Overall minus information that is received after splitting based on Q1. Okay, similarly you do for Q2, then find the information gain. So we've got this information gain. So gain Q2 is more for Q2, it will be selected as the splitting attribute. So for whichever attribute you are getting more information gain, that is your best split attribute. So this is about information gain. Only it's all same like Gini only, same like in classification error only. Only difference is formula is this. That's it. Okay. So this was information gain. Another way is gain ratio. Gain ratio is gain that you got by split info of A. That means if you want to find out the gain ratio for Q1, if you want to find out the gain ratio for Q1, you have to take gain of Q1 by split info of Q1. That means you have to take, what is the gain of Q1? How much you got? Where is Q1? Where is Q1? Q1 kahan pe? Yeah. Where did I calculate Q1? This is Q2 information. Yeah, here it is. Q1. Okay. How much gain you got for Q1? 0.229. What was the split information for Q1? What was the split information for Q1? So split info for Q1. There is, yeah, 0. Split info means without total 0.989. So that's what it's written here. This is what the formula. So we have already calculated above, so I'm not doing it. So split info of Q1 is 0.989. So similarly for gain of Q2 and total split info of Q2, and then you can calculate your gain ratio. So attribute with maximum gain ratio is selected as splitting. Again, whichever has maximum gain ratio, that is selected as splitting attribute. Here Q1 has maximum gain ratio, so Q1 is selected. Here also Q1 only we selected. No, here we selected gain Q2 is more for okay. So gain for based on gain ratio it is different, based on gain it is different attribute is coming. Now, this is another problem. This is just different type of problem. Here if you see, we are calculating. So this is the problem from previous mid-sem. It was given. Okay, here if you see, This is the table. This is your target class. Now they will ask you to calculate which is best split, age or income or student or credit rating. So you need to go one by one. First you should take age. Draw the contingency table. In age you find out what are the three different types. Less than or equal to 30 is one type, 31 to 40 is one type, greater than 40 is one type. So we draw the contingency table right here number of positive, number of negative. That means for less than or equal to 30, which all are negative? No. Which all are no? That you write here under N. Which all are yes? For less than or equal to 30 only you need to check. Okay. For this less than or equal to 30. Which all are yes? Right here. Positive mein. Okay. And then 31 to 40. Which all are yes? 1, 2, 3, 4. Right here, 4. So like this, you draw the contingency table. So we consider class P as bias computer yes. That means we write here all yes values. Class N as bias computer no. We write all no values here. Same thing, you calculate your information, total, overall information. Overall, how do you calculate? What is this 9, 5? 9 is number of positive and number of negative. So 9 is number of positive, 5 is number of negative. So this is overall how many positives you have, how many negatives you have. So based on that, you calculate the overall information. Now information at age, information for age you have to calculate. How do you calculate information for age? Now how many types are there here? 1, 2, 3. For each type you have to calculate. How do you calculate for each type? What is this 5 by 14? For each type total how many you have? 2 plus 3, 5. For age less than 30, how many total classes you have? 2 plus 3, 5. 5 by total number of values, how many you have? 14. Into information of I of 2, 3. That means information of positive and negative. So how do you read this? You read this like 5 by 14 I of 2, 3 means age less than or 30 has 5 out of 14 samples, has 5 out of 14 samples with 2 yes and 3 no's. Okay. Similarly, if you have to calculate, you have to add. In the formula we have summation, right? You have to add for this type now. So for 31 to 40 total how many you have? 4. That means 4 by 14 into I of 4, 0. That means 4 out of 14 samples has 4 positive, 0 negative. Similarly, you calculate for this and right here. So you will get the information based on your age split. So now you got the information based on your age in total overall information. Subtract that, you will get gain that you got after you split the table based on your age attribute. Similarly, how you did for above, same steps you do for income, student, credit rating. And then you see whichever is having more gain, that will be your best splitting attribute. So which is having more gain here? 0.246. That means your age. Okay. Here they have calculated gain ratio. They are trying to calculate split income, split info of income. Okay. Based on income, they are trying to calculate the split info. And then they are finding the gain ratio. Okay. Gain ratio, how they are finding? Gain of income. Gain of income is 0.029. And split info of income, this is the formula that they have used and they calculated. Okay. And then they got this one. Attribute with maximum gain ratio is selected as splitting attribute. Here, don't get confused. I just did gain ratio for only one attribute, income. You have to calculate gain ratio for age, gain ratio for student, gain ratio for credit rating, and then decide whichever has maximum gain ratio, that will be your splitting attribute. So that was all about how do you classify based on finding the information gain or entropy or Gini or classification error. how do you find which particular attribute is the best attribute? Okay. Now coming to rule-based classifications. This is the last chapter, and here we use some rules to classify the particular tuple. Okay, given tuple from X from a class labeled dataset T. So if suppose any tuple X is given, now this tuple, let n covers be the number of tuples covered by rule R. I think I assume that you all know what is rules. Okay, so we will be writing some rules which will predict our class, target class. And if I say that my n covers is the value which is the number of tuples that is covered by any particular rule R, and n correct be the number of tuples correctly classified by R, and D is the total number of tuples in D, then I will say my coverage of R, how much my rule R is covering is n covers by D, and accuracy is n correct by n covers. Out of that n covers, suppose it has covered 4 tuples, out of those 4 tuples, how many it has classified correctly? Okay, that is your accuracy. We will see the problems, then you will understand. So let positive be the positive, negative be the neg be the negative tuples covered by R. So in class we have positive and negatives, right? Target class. So let number of positive be positive and number of negative be negative, that is covered by R. And positive dash, negative dash be the negative tuples, positive and negative tuples covered by R dash. There are 2 different rules now, rule 1, rule 2. We have to decide which rule is better. In order to decide that, we calculate FOIL gain. So FOIL gain is nothing but information gained with rule 1 and rule 2. Okay. So you calculate FOIL gain. Okay, and then based on that we decide. This is a FOIL prune. FOIL prune means if this value is higher, then you have to prune that particular rule. If you calculate for any particular rule, FOIL prune. Okay, let's first see the problem. So this is a problem. So these are some rules that is given to us, R1, R2, R3. Okay, R is given by A to Y. A is your rule antecedent, Y is your consequent, Y is your target class. Okay, now if you see coverage of R1, how do you see coverage of R1? How many tuples it is covering? Defaulter no. Okay, homeowner yes, defaulter no. How many? 1, 2, 3, 3. How many it is covering? 3. Total number of tuples 10. 3 by 10. How many it predicted correctly? Rule is homeowner yes, defaulter no. How many it predicted correctly? All the 3 it predicted correctly. So 3 by 3 is equal to 100% accuracy. Okay. Similarly, for coverage of rule 2. Now what is rule 2? Marital status married. Marital status married. It is your output? No. Married? No. 1, 2, 3, 4. Just a minute. Hello? Yeah, sorry. So how many we have? 4. So 4 by total number of tuples 10. So coverage is this. What is the accuracy? All 4 correct, right? 4 by 4. Similarly, you can calculate for R3. Now, if you see whichever has high accuracy, that will be your stronger. But here all are having 100% only. Okay. So we will see another problem, then we will see the differentiate. So if you see this one, consider a training data set that contains 60 positive samples, 100 negative samples, and R1 covers, let's say, 50 positive samples, 5 negative samples. R2 covers 2 positive samples and 0 negative samples. Which rule is better? Okay. Now coverage is, total coverage is, how many it is covering? Total 50 plus 5 negative. That means 55 by total number of tuples 60 plus 100. Total 60 positive and 100 negative samples are there, right? So 160. So this is coverage. Now accuracy of R1. Accuracy will be how many positive it has covered. Okay, that will be your total correctly predicted. By total coverage is how much? 55. So 50 by 55. Similarly, you can find for R2. Now, which one is better here? For R2, you are getting 100%. For R1 is this. So R2 is, see, R2 is 100. What is the coverage of R2? 1.25% only. And coverage of R1 is 34.3%. I'm not sure whether this statement is correct or not, but this is what it is written in textbook. R1 is better despite its lower accuracy. The high accuracy for R2 is potentially spurious because of low coverage of rate. Basically, this looks, I mean, logically speaking, this is correct because it is covering 1.25% of tuples only. And if you see accuracy out of 160, only 2 only it is covering. So that's why it is getting 100% accuracy. That's why you have to, in exam, you have to check this, okay? Just don't write blindly. If it is 100%, this is a better rule. We have to check this also. Coverage also. How much, what is the percentage of coverage? Here, it's huge difference between this and this, okay? Yeah. Next is foil gain. Foil gain, this is the formula. Okay, this is the formula. So for foil gain for R1, how many positive? 50. Positive by positive plus negative 5. And this is what? This is your total. 60 positive samples by positive plus negative. This is very, very, very easy. Okay, you can just substitute directly. So this you will get foil gain. So whichever foil gain is more, so R1 will be, that will be better. So here you have more. So R1 is a better rule. Okay. So based on foil gain also, you see you are getting R1 better. That means R1 is only better. Okay. Even though its accuracy was less here, but if you see foil gain also, R1 is only better. Okay. Next, model evaluation and selection. How do you evaluate your model? So this is the confusion matrix that you should create. Here you write predicted class, here you write actual class. True positive means how many it predicted positively correct. False negative, actually predicted is negative, but actually it is positive. That means false negatives. Here actually negative, but predicted is positive. That means false positives. Here true negative, that means predicted is also negative, actual is also negative. So you draw this contingency table, and then these are the formulas. Just by heart these formulas. Okay, accuracy TP plus TPN by P plus N. P is total positive. TP is true positives, number of true positives. I'm not going to deep inside. These are very simple formulas. Everything depends on this. Just use this as it is. Okay. This is for recall, precision, F score. Okay. I'm not at all explaining this. So let's go to this one. So you draw table when it is given to you, and then you substitute the formulas. I wanted to explain one important thing here. Yeah, this one. Simple linear regression. Okay, there is one problem given in midsem also. They never mentioned linear regression. They have just mentioned one word called linear. So I mean, at one glance, you will not understand that this is the one that you have to do. Okay, just I'm telling you. So linear regression means you are checking how your x and y, what is the relation between your x and y. Okay, when you this is nothing but a slope intercept form we have in maths, right? Fy is equal to mx plus c. So this is that kind of equation, slope intercept form. Okay, so how do you calculate this linear relation between x and y? So you will be given x and y values. So you just use this formula blindly. Okay, W0 and W1. So this is the formula for, this is the linear relationship. Y is equal to W0 plus W1x. W0 is your y intercept, W1 is your slope. Okay, and then find out, this is the formula. Okay, for W0, this is the formula for W1. So you find out here, you want xy, find out xy. You want x square, find out x square. Then you want summation, find out summation. You want summation of x square, find out summation of x y. Okay, substitute here. Okay, just remember this is sigma of x, summation of x whole square. After you do the summation, then you have to do square. But this one is summation of x square. After you calculate x square, then you have to do summation. Just don't get confused. Okay. and then substitute in this. After you find W0, W1 value, substitute here. So what they will give you, in problem, they will give you some X value, and then they will ask you to find Y. So after you find this linear relationship, find out, substitute your X value here and find out the Y value. And they will ask you to do some inference from that. So here in the table, you add two more rows, two more columns. So now this is your predicted value. That means if you substitute your X as 1, then as per this equation, Y will be your predicted value. This is Y, your actual value. Again, you substitute X here 2, then this is your Y predicted value. Okay. Similarly, they will give you some one more variable value for X, let's say 6, and they will ask you to predict your Y value. Okay. So here this is the error. So this was actual, this was predicted. This is actual, this minus this is your error. Okay. So this is important topic, guys. Next, yeah, association rule analysis. I'll just quickly finish this. So how do you do? So this is one important algorithm, a priori algorithm. Okay. But just once I will tell you how do you do this association rule analysis. You do it based on the support count. Support count is nothing but frequency of an occurrence of item set. Just 2 minutes. I'll have water. The support count here is frequency of occurrence of an item set. Now, this is the item set given: milk, bread, and diaper. Okay, it contains K items. Now, what is your support count? How many times this combination is occurring? Milk, bread, diaper. Milk, bread, diaper, here, here. So, what is your support count? 2. Now, if they want you to calculate fractions of transaction, what is your support? That is fraction of transaction that contain an item set. Fraction means out of this total. How many are total? 5. How many you have with this item set? 2 by 5. That is your support. Now, which is a frequent item set? How do you calculate frequent item set? An item set whose support is greater than or equal to minimum support threshold. Okay, you will be given with some threshold value. So whichever item set has support greater than this minimum support threshold, that is your frequent item set. That we will see how to calculate. Now this is your association rule. X and Y are item sets. In X you have milk, diaper, which implies butter. Okay. Now fraction of transaction that contains both X and Y, that is support count of milk, diaper, butter by T. So milk, diaper, butter, it was coming in 2. That is your support. If they ask you to calculate support, you have to find fraction of transaction that contains milk, diaper, butter by total. Okay. Confidence, measure how often items in Y appear in transaction that contain X. Try to understand this definition. What is the definition of confidence? Measure how often items in Y. What is item in Y? Butter. Y is your butter. X is your milk and diaper. How often items in Y appear in transaction that contain X? So what are all the transactions that contain X? What is X first of all? Milk and diaper. Milk and diaper. Milk and diaper this. So butter comes here. Yes, 1. Milk and diaper. Butter comes here. Yes, 2. So that means how many? 2. So what is your confidence value? 2 by milk diaper. Milk diaper means how many X you have, how many tuples you have where you have this item set, milk and diaper. Milk and diaper. Milk diaper 1, milk diaper 2, milk diaper 3. That means 2 by 3. So for while you calculate confidence, it is not total number of tuples. It is the tuples where you have your X, where you have occurrence of X. Okay. This is how you calculate support and confidence. Now coming to a priori algorithm. In a priori algorithm, you calculate which is a frequent item set. I will quickly tell how do you do this. So you will be given with such some data set. You have to calculate which is the frequent item set. Okay. Minimum support value will be given. Threshold confidence value will be given to you. First you find out what are all the different items. 1, 2, 3, 4 and 5. Jot down, okay? 1, 2, 3, 4, 5. Now what is the support for our 1? How many times 1 is occurring? 1, 2. 2 divided by total number of items, 4. 2 by 4. This is your support value. Now coming to 2. 2 how many times is coming? 1, 2, 3. Support is 3 by 4. 3 कहाँ पे आ रहा है? 3 where it is coming? 1, 2, 3. 3 by 4. Okay. 4 is coming only here. 1 by 4. 5 here. Calculate the support value. Okay. 5 how many times? 1, 2 and 3. Sorry, 3 times. 3 by 4. So calculate the support value. Minimum support, how much we have given with? 50%. Now, whichever support value is less than 50%, drop that. You're not considering this one. 4 you're not considering. What you are left with now? 1, 2, 3 and 5. Now this we have taken combination, we have taken single. Now take the 2 combination. 1, 2, 1, 3, 1, 5. 2, 3, 3, 5. Put it in the table. Now where you are getting 1 and 2 both? Where all you are getting 1 and 2 both? 1 and 2. Only one place. 1 by 4. Calculate the support value. Where you are getting 1 and 3? 1, 2. 2 by 4. Where you are getting 1 and 5? Both should occur. 1 and 5. Only at one place. 1 by 4. Support. We are calculating support here, guys. So 4 is nothing but total number of item sets. 2 and 3. 2 and 3 is 1, 2. 2 by 4. 2 and 5. 1, 2, 3. 3 by 4. Now here minimum support is 50%. Which is less than 50%? This one. We will not take this one. We will not take this one. Now we are left with this and this. Make the combination of 3 now with this one. 1, 3, 5, 1, 3, 5, 2, 3, 5 and 1, 2, 3. Only these 3 combinations you will be able to. You can write here and then check. 1, 3, 2, 3. You are left with and 3, 5 and 2, 5. So what all combinations you can make? 1, 3, 5, 2, 3, 5 and 1, 2, 3. No other combination will come. Okay. Again you calculate. Again you check for 1, 3 and 5. 1, 3 and 5. Where it is coming? Only here. So 1 by 4. 2, 3 and 5. Here. That means 2 by 4. 1, 2 and 3. 1, 2 and 3. Only here. So now again you see minimum support value is 50%, which is less this one. So don't consider this. Now we are left with only 2, 3, 5. So this is your frequent item set answer. Okay. So similarly, we have one more problem. I'm not explaining. This is, you can do it. Okay. So this was all about DM. I am unmuting. Let's take for 5 minutes. We have 12:45 minutes. Problem? Any questions? Any discussion? Okay, and then we can wind up. I unmuted.
Hello, Anu. This is Saklan. What is the use of confidence in the last behavioral version?
Yeah, I don't. That's what they just gave, but I don't see any. I mean, I didn't find anywhere we using this confidence value. But generally, they say that you can use the.
So,
I mean, you can calculate
just
confidence here and then compare with confidence. Maybe your confidence should be greater than minimum confidence. Support should be greater than minimum support.
just to add, the confidence is used basically, see, when you have the different rules, right? R1 and R2. So which is having more confidence that we will take.
Okay, so for rule comparison.
Yes, it's a rule comparison. So in the question, definitely they will give like some rules. So we just apply that and see like, if it is meeting or not. Yeah, it's a rule comparison.
Okay. Yeah. Thanks, Anu. Great session. Thank you.
Any doubts? Please tell me.
Thanks.
I'll just take 5 minutes. Any questions? Anything you want to ask, or else we can just wind up. Okay. Thank you all. It was a great learning for me.
Thanks, Anu. Thanks, Anu.
Thanks, Anu.
Can you
Great.
please
Anu, can you send this document in group or
Thank you, Anu.
Yeah, I will send.
yeah, thank you. Thanks a lot.
Yeah.
Happy New Year.
Thank you, Anu.